continue our application today, and just in case everybody is not on the same page, so what our application is going to do, and it's doing at the moment somewhat, it gives you navigation instructions from point A to point B. Presumably you are at point A, so maybe we will link point A to this geolocation, what we just saw before. But the navigation instructions are going to be given so that it also shows how much wind is going to be on the path. So the idea at the moment is we are getting directions, street navigation instructions from OSRM server that is also installed on CS server, and we call the overpass server for this contextual information, like the forested areas, which are presumably not very windy, and also building information is also retrieved, because sometimes it's possible to go through different buildings, like in Joensuu at least. It is possible to get routing instructions that take you through a little bit through some buildings, or more through some buildings, and I assume it's also not windy in there. We will later augment this, probably tomorrow, because if the wind is going, for example, from the east, and this building is probably going to shelter very much on this road, so this place here is quite pleasant, most likely. But these are just assumptions, and we will need to test this outside to see if it really works. Anyway, so this is what we have now. We get contextual information every time we drag these two markers. And we noticed the bug that I think Georgia pointed out, that if we have the markers in such a way that the trajectory is going to be away from this bounding box, that means that we don't have contextual information on the trajectory, and that's what interests us. So we definitely need to have contextual information next to the trajectory to make the decisions. And that's going to be the first change that I'm going to make, so I don't forget about it. So let's see how this would affect our code here. Yes. It switched off. Still works. Great. Now I don't regret missing Black Friday. Okay, so our update context function, this function was called every time we needed new context, gets bounds from the markers. So this just means that, I remind you, these bounds here are going to be where the context will load from the overpass server. But we want to include in the bounds the response from the getDirections function. So I'm going to modify this a little bit. Can you hear me fine in your answer?
Yes.
Okay, good. I'm going to move the code from here inside somewhere where the getDirections function completes. So let's think how we do that, because this is new issue that I didn't really consider much. So the get directions function will get directions between every pair of markers. I also have to remind now that it's possible that we have multiple waypoints in our navigation here. And for each of these, we would need to calculate the new bounds. So the get directions function calls the OSRM server, and when the response is retrieved, we get onDirections_retrieved function from here. Okay, so one way of doing it, because I want to now contain definitely the bounding box of all the points in this region. I'm going to create a new bounding, bounds object from all of them in the following way. I will create a global variable, so this is going to be our bounds, and for now I leave it as null. And in the get directions onDirections_retrieved function, I'm going to update these bounds with every new point that is coming into the polylines, into the lines on the map. So yeah, this is what I need. So instead of calling this get bounds from markers, I'm going to use part of the code here and extend the bounds of this global variable to each point of the polyline. So let's do it this way. So this polyline point goes into the polyline as before, but also is used to extend the bounds of my now defined global variable here. Yes. Now this global variable that is null, defined above, needs to be initialized to an object of the type LAT-LNG bounds from Google Maps API. We initialize this before starting to call any of the directions. So this get directions is called between every pair of points, every 2 consecutive points. Before we start to call these directions, we need to initialize the bounds again, because they will later be updated by all the different requests from the get directions. So these bounds are going to be now extended here on directions received, and when all of these complete, our bounds must contain the entire region. The problem is that I don't know when this on directions received when all of them complete. So if we go back here and do debugging in the console, if I have just A and B markers and I'm going to move them, sorry, I need to show the HTTP requests here. If I move these markers, first request is going to be this get directions request here. But the other two are something else. They are the context information. So this is getting the forest information, and this is getting the buildings information. But if I have 3 markers here, so with 3 markers, I now have 2 get directions requests. I have the first and the second, so from A to B and from B to C. And these are asynchronous requests, means that one of them may finish before the other. They will need to be, how to say, I just need to know when all of them are going to be completed. And there is no simple way of doing this, to my knowledge, other than counting, just simple counting. So I'm going to do this following thing here. I'm going to say directions request count, a variable, and this directions request count, I'm going to use it when I start getting the directions here, and also when I initialize the bounds. So I'm going to say I am expecting to get markers dot length -1 requests. So if I have 2 markers, I will have 1 request. It's just A and B. If I have 3 markers, I will have 2 requests, A, B, and BC. So it's always going to be marker length -1. And when the request completes here, and where I also extend my bounds with every point, I will say, I will decrease the count of requests that are still pending. And if the value is 0, or I put the less than 0 just for sanity check, then all of them have been completed. All of them have completed. So at this stage, I know that all of the lines are drawn on the map between AB and BC, and CD, and DE and EF. So that's our limit for the moment. So what we do here in this case is what we did before. Set bounds, but now I'm going to set the bounds not from markers anymore, so this is obsolete. We are going to set them from our bounds that were extended to contain all the points from, just a second, all the points from all the polylines. So this is one thing that we can do here. No, sorry. This would change the map. This would change the map to the bounds. We don't want to do that. We want to call for the context information. So we want forests and buildings to be called for in these new bounds. So we had the function for updating the context, and this was called also with the bounds from the markers. So it's something we don't want to do anymore. And we won't even need to call it here anymore, because it's going to be called when the directions complete. So yeah, a little bit confusing here, but it's because I got this just a few minutes ago, so I didn't prepare how to explain it better. Okay, so now when the directions are retrieved and all the requests delete, we can update the context with the bounds that should now contain everything, if I am not mistaken. And anytime we are getting directions, we don't need to worry about the bounds anymore because they will be calculated in the callback function. So I can remove actually this code in this code entirely. And this would not be needed here. So let's see if we got it to work. I refresh the page. I open the console so that there are no, so I see the bugs if there are any. So, okay, there is a bug here. It seems like the context is called twice when I'm loading the page for some reason. But let's ignore that for a brief moment and see if we solved the previous problem. Okay, so it actually works. Now when the trajectory goes below the bounding box of A and B here, we do get building information and forest information in the bottom, because now the bounding box is calculated here until this bottommost point. But here we are getting, for some reason, 2 requests for context. And it's causing this other bug that I think somebody else pointed out before. So let's see why this is happening. I'm going to go back to the network tab, refresh the page, and yeah, so we have a get directions call here, another get directions call here. It should be just one. So there are 2 get directions calls that are happening one after the other for some reason. Okay, I think I know. Okay, this one here is not needed. So the reason is the add marker function, every time a new marker is added, this function right here, every time a new marker is added, if we have more than or at least 2 markers there, the get directions function is called anyway because it needs to be updated. So the problem is now we are getting that from the second add marker call in the initialization function here, but also here. So this one we can live without at this stage. I'm also going to say to this function get bounds from markers now not used anymore. I don't know if we will ever need this anymore, but so I keep it there a little bit for now, but at the moment it's not used because now the markers are coming from the other place. So if I refresh now, okay, now there is no more bug. So this request at the beginning, there are not 2 requests coming one after the other causing that problem to appear. You will also notice that in this case, application is slightly slower than before. It's a bit slower because now we don't have the context requests and the directions requests happening asynchronously at the same time. The context happens after the direction requests response. So it waits for something. That means that overall the response comes a little bit a little bit later. We also have another bug pointed out by somebody, that if I move these markers really, really quickly somehow, now I get the same effect from before. I have the lost references because something is loading, and then I trigger by moving rapidly to load something else while that something that is loading is not completed. So what happens is that some of the references that we have overwrite the previous ones, and these become, I lose the pointer, I lose the reference for them. I don't teach how to fix this in the code because it's more tricky. I would need to trigger canceling the previous request and canceling the drawing on received. But I will solve the problem in another way. I will make the map unclickable until the results come back. So now it allows me to do this moving the marker even though some things are still being calculated, but before I get the response I will make the map unclickable, and in that case the problem will not happen. It's not the best thing to do from usability point of view, because people may want to do this kind of thing if they make a mistake. So we talked before about mistakes and about allowing users to fix it. If they need to wait every time they draw this for something to happen and then they can move the marker again, then that affects their feeling empowered during the application, and they feel like, okay, application is controlling me, not me, the application. This won't be a very big issue here because the server where Overpass and OSRM is in Finland and it doesn't have much load, but if this kind of request would take, instead of 2 seconds, 10 seconds maybe to complete, this will affect usability. But I'm going to do it anyway because we need to finish this. So today and tomorrow we will finish this application. And let's see, I will do this by just drawing some very big thing on top of the map, and I will shoot 2 birds with 1 stone. This thing will also say loading. So I'm implementing a progress indicator that says that, okay, you dragged something, something is going to happen, wait for it to complete. So I'm not just disabling the features. And very easy way to do this is I'm going to make here a div. Let's call it loading. And I'm going to put the text inside loading ... And that's it for now. I'm going to refresh the page. It's not here. Oh, it is here, but why is it at this level? I may want to have it on top because I want to see it over the map. Yes. Okay. So it's here, but I don't like at all the way it looks like. So now we modify it with CSS. First thing, I will make it cover the map. So to do that, I will set the position to absolute. So this is the first thing that we need. Otherwise the map gets moved down by the div. Then it disappeared. It's actually now behind the map, so it will need a z index of something. I'm going to put a z index of 1. So now the loading is on top of the map with the z index of 1. Now the background, I want the background to be an a transparent white. I still want you to see the map, but I don't want you to see it that well anymore. So I'm going to say RGBA, so red, green, blue. Alpha stands for transparency. White is 255, 255, 255, and I want an alpha of 0.7. So you can see now here a little bit that there is a white rectangle around the loading text, but I want it to be over the map. So my width is going to be 100% and my height is going to be 100%. And now I want the text to be somewhere better, because now it's here, it's small, it's we can do better than that. And it also will look very bad on a small screen or on a big screen. This text needs to update its size similar to the markers do. Font size, I'm going to use the viewport measurements, not the pixels. So I'm going to say here maybe 5V min. So V min, if you don't know, so VW means 5% of the viewport width. VH means 5% of the viewport height, but V min means 5% of the minimum of the width and height. So using these, now if I refresh the page, the loading, you can see it changes size. It changes size, and at some point it stops changing the size because the minimum starts to be the same. So now the minimum is by the bottom side. It's still growing, the loading, the size of the loading, and at some point it stops because now minimum becomes the vertical axis, and this vertical axis stays unchanged from now on. I'm going to put it bigger, maybe too big. Something like that is fine. I will also make it center, so that it's in the center of the screen now. And I personally don't like very much I believe this is Times New Roman, or I'm not sure what font it is, but I think Family, if I don't forget. So font family. I think it can be like this. So okay, I'm going to copy all this CSS that I experimented with here, and I'm going to make a new CSS class on the top here for this loading. So CSS, it's not a class, it's I'm assigning it to the div which has the ID loading. It's the only thing that will be like that. There is no point for me to make a reusable class here. So now this is going to work. If I refresh the page, I'm going to have this, but now I have this and I can't work with the map at all. So it's disabling the map for me. It's showing me the progress indicator, but it should also go away when the context and everything is loaded, right? So I need two functions, one to make this appear and one to make this disappear. And I'm going to write these two functions maybe at the bottom of everything here, since they are not very important. I mean, not interfering with the programming, the other logic of the programming. Show loading, and this is gonna be probably that. So hide loading will add the non-display attribute there. think we can begin with the loading on, because most likely, like any application, it needs to load first. But now if I refresh the page and if I go to the console, I can say hide loading and it goes away. And now I can move the map, but if I'm going to call show loading, it shows, and I couldn't make the bug appear again. So I have this progress indicator that yes, we are loading your context, and so on. But we now need to figure out when to show the loading and when to hide the loading. So we show the loading every time directions will be calculated. So, for example, okay, let's see where they are calculated. So they are calculated in get all directions on marker click. I think there needs to be a check here. If marker's length is greater or equal to 2, then I get directions, because if I have just one marker for some reason, there's no need to do it. So this needs some kind of sanity checking. On marker drag, I think this should apply everywhere. There's no need to recalculate directions if for some reason I already had it here somehow. Okay, but when we are doing it, we will show loading. We show loading, and then we stop loading. Well, we don't know where, we can't just make it easy now. I could stop loading here where we have all the directions completed. Let's do it. But it's not the proper place. We do it now just to test if this system works. Okay, so loading disappeared. That means something happened. I'm moving it. It appeared briefly. It disappeared, but you see the buildings haven't loaded yet when it disappeared. So my hide loading needs to go not when the directions complete, but when all the contextual information is also there. So it's not now in the proper place. It needs to go even later, after all of the 3 request types. In case in your so you haven't figured it out, it's much louder than before. Does the micro... I guess the micro...
What is the syllabus for? I mean, what should we expect?
I'm sorry, you will have to repeat, but...
what do we have to prepare for the examination?
Will you do a project? So you then go just to the written exam. So if you go to written exam, do you have
Yeah, I want to give the written exam.
Do you have enough exercises to go to the exam? You need 20 exercises. You need 20 exercise tasks completed to enter the exam. I know how many you have already?
So I've attempted 4 of those exercises. So each one has many problems, so it should be more than 20.
But were you in class? Because you need to be present.
I was in class in 3 of them. One I attempted.
I will make an update with how many points everybody has this week. But I think you weren't today in the exercise this morning. This morning was the exercise session, 8 o'clock. So for the exam, the same type of questions as in the exercises are going to be. But many of them we address also during this, this lesson now concerns very much those who make projects, but many things like usability or interface, questions like this can be at the exam as well, like what makes a good interface, or give examples of 2 bad decisions. So many times even in programming like this we address like you have progress indicators informing the users this and that, or this is what we do now. So this also reinforces what you learned during previous lectures and during exercises. If you are managing fine with the exercise questions, then similar things will be at the exam. A little bit of math like in the beginning, but then more or less moving towards user interfaces, how location is useful and things like that. Okay, I will write some code now and explain what it does.
Okay. So this week you will be...
I will be here today, tomorrow and Thursday.
You will be updating like who can give the examinations if they want to this week.
I will make a list of how many points everybody has. You need 20 points if you don't have a project, and I will also have to put the next 2 exercises. So at least 12 more points you can get in the next weeks. I may put even extra tasks if somebody is lacking. So
the exam is on 13th and the project is on 12th.
yeah, project presentations will be on the 12th. So here, and the last lecture is here, but it won't influence the questions from the exam, and the exam is here. So you will come on 13th, 12 o'clock, Kantia 101. Yes.
Yeah, I was sent an email about coming late tomorrow, today, and I was wondering if you were asking something about the questions. Name was
talk to me after today. I have now the camera on, so I don't want to put like grades or student numbers here to interrupt. But okay, I think anyway I can mark you as present, so no problem. Okay. Sound is better.
Yeah, I think this is one of the reasons why people really like videos instead of...
Video has the same thing.
Yeah, that's kind of
but you can lower the volume. Okay, so yeah. So when we retrieve the directions result, so here we know that all the directions between all the markers are calculated. This is where the updating the context starts. So our updating of the context will get the forested areas and the building areas with two different HTTP requests. And we will use here the same strategy as before. I have how many requests I'm going to have? 2. I'm going to have the forests and the buildings. And every time one of them completes, I'm going to subtract 1 from it. And when this value becomes 0 again, it means that I can finally show, hide loading. This is now some duplicate code here. I could make a function, but I don't bother. It's just one line, at least for now. Maybe later I will have to separate. So hide loading in this case. And I need to remove the hide loading from this other place. Okay, now the loading lasted longer time, and when I do this, you see that the forests appear, and then the buildings appear, and then the loading indicator disappears. So now the user cannot make that bug appear because he cannot drag meanwhile. But as I said before, if this space would be very big, like now retrieving many buildings from halfway to Kuopio, then the user has to wait a very long time. But then again, this application is meant for people that are walking, maybe cycling, so the distance is not as big as going to Outokumpu or wherever is this going. So this is one more thing that can be an issue. What if you put one of them in Helsinki and the other one in Joensuu? It's going to load all the buildings from Helsinki to Joensuu, and you will have to download like gigabytes of data maybe. This issue you can solve by some ways, optimizing even better so that you don't get this big box, but only the regions next to the line is one thing that you can do, but very complicated. I don't have time to implement such a thing, even though that would be the best. But other thing, you don't want to walk from Joensuu to Helsinki. This is out of the question, and if you're by car, the wind doesn't influence, so you don't need this app in the first place. You could limit this problem by setting a limit on the zoom level of the map. So if you're at this zoom level, you may allow the person to play with the markers, but maybe not allow the user to go above this level. This is already city level. It's very unlikely that they will go more than, this is about 2 kilometers here. Maybe this would be like the maximum zoom level, but allowing to see something like this is unnecessary by this app. It actually means that if this would happen, most likely user would have to do many clicks and go back to where he was. Maybe he did a mistake, or the phone got wet, and when it's wet it can go press different buttons and so on. So if we would fix the zoom level, the maximum zoom level, so that it doesn't go maybe above this, it solves many problems. It doesn't overload the server in case the user accidentally drags to Helsinki. It doesn't move the map automatically if the screen is wet, or these external factors like maybe gloves that make it unprecise when you're working, and maybe you accidentally press this button like 20 times just by touching it slightly with the damp finger. This stuff can happen. It's usability related. So if you set a limit on this zoom level, you actually do many good things, and we can try to do that. I don't know how to do it, but I know how to hide, how to search for information online. Okay, very complicated. Not really. So just this max zoom. We need to, in our init map function, where we have the map here, we need to specify a max capital Z, capital zoom of, well, let's see what is the zoom level here. So we can actually get the zoom level by map get zoom 12. So if we have this code here, it may be enough. I think so. Oh, sorry. Now I can't zoom in anymore. It's mean probably, most likely, I'm going to guess. Now I can zoom in, but zooming out just doesn't work anymore. So small trick I'm doing here, but it will impact usability. Okay, great.
I have a small question. When we updated the bounds to take into consideration the road, wouldn't it have been better to just take the extreme point of the road, like it would have reduced the server load or something?
No. So what I'm doing is I'm actually extending the bounds at each step.
Okay.
But to get the extreme points of the road is still a linear time complexity.
Oh.
Because you have to check if each point of the road is going to be the extreme or not.
Yeah,
It could be that the extending of the bounds function is maybe not a constant time operation, but I doubt it. So if the bounds extend would not be constant time, but I doubt it because I know how, I could implement a function for extending bounds in linear, in constant time, so why wouldn't Google do it? So from time complexity, it's the same thing. Maybe it would be a little bit faster, but it would be hardly noticeable. I don't know. So, yeah, but very good question actually. Because for some things, like for example, if I would use this with MOPSI trajectories instead, in the exercise class before I gave examples that you could use this app to figure out where to go cycling today, considering your previous trajectories. Those already have the bounding boxes calculated in the MOPSI database. So that would be constant time retrieval of the bounds, not linear time retrieval of the bounds. So, because I already have them calculated. In that case, very good point. So you could use something like that. Yeah, thanks, good question. Okay, sound is coming again. Let's have a 10 minutes break, and then what we are going to do, we are gonna show the parts of the road in red that are gonna be windy. And that's what we are gonna probably finish. I hope we can finish today, if not tomorrow. I'm gonna start a bit before the break because I will copy some things from the first from one of the first lectures, this Lamad Earth lecture. I'm going to copy the distance calculating functions because we will need them here soon. So for that I need this global variable of the radius of the Earth. And I need the Haversine function. It uses the Euclidean function, and these other things. I'm going to copy them also here at the bottom of the page. They will be useful for us today in different parts, and this fix has been applied, so it was explained here. I'm just going to remove the comments. I started this already now, even if somebody is still in the break, because everybody should be familiar with this code already, so it's not missing anything really. It was, I believe, the second lecture. And now if I have Haver sign of, let's say, yeah, 1 degree of latitude. So you know, 1 degree of latitude is about 111 kilometers. So function seems to work fine here. This is in kilometers here. Of course, you could have it in meters, and maybe it's a little bit nicer to have in meters today, because the distances that we work with are not that big. When you walk somewhere, it's usually like 1, maybe 2 kilometers, but if we are going to calculate distances, it's just more likely that we will use a meter representation. So I did also this now, and yeah, I closed the other file so it doesn't confuse us here. And now if I refresh and I test the Haver sign, I'm going to get 111,194, and this will be a meters. Okay, and since we are here, let's calculate the length of this route from A to B. So it would be interesting to know this at some point later on. Somebody was also commenting in the exercises that you would like to know how long it is, but I also mentioned it would be nice to know how long you have to go in the windy section. So it's most likely a component that we will use. Wow. Wow. This is horrible. Okay, so to get this a length of a line, of a polyline, so now our polylines are in this global variable polylines. It has only one element now, but if we have 2 markers here, then our polylines will have 2 elements. So if we say polyline of 0, we will get the first polyline. If we say get path okay. If we say from that get array, we get the 17 points that make the path from A to B. So I assume that A to B has 17 points and B to C has 33 points. Yeah, B to C is longer and it seems to have more complexity in some places. So I believe this is correct, but this array now is of this Google LAT LNG object. So it's useful to have a function here, get point array from polyline. And we are given a polyline. And what I'm gonna do is, wow, is I'm going to call this path that we found out in the console now, and the polyline is not anymore, it's a parameter given here. So the point array should come like that, but the problem with it is that it's going to be in the Google format, in the Google LAT LNG format. So I'm going to make it in the format that we have used everywhere with all our functions, and I will create the array from scratch. So point array is a new array. And I go through all the polyline elements, and I say to push in this array a new point that is just a point that is, oh sorry, this is the array. The element at the I position, let's see, does this work? Yeah, and then that LAT, the method LAT, so I will put the result in the LAT attribute, and then the LNG goes in the LNG attribute. So I return this. This function more or less doesn't do anything. It just formats the data in the manner we are familiar with from the first lectures and our functions. I remind now the Haversine function, the Euclidean function, these distance functions, they all work with objects that need to have a LAT and LNG attribute. So we convert the Google object into this. It's nothing magic here. And with the Haversine function, we can calculate how long are these polylines in meters now. Because it's just calculating the distances between every consecutive 2 points. So I'm going to do that like function get polyline length, and I'm going to write it like first I get this array that I can work with my distance functions. And now I iterate through the points except for the one at the end. So I'm not going to consider the last point here. And I'm going to calculate the Haversine distance between the point at I and the point at I plus 1. So the reason I stop here before the last one is so that I will include the last one in the previous step there. So this distance is going to be added to a variable total distance initialized to 0. And this is going to be also returned by our function. So this is now the length of one polyline. We can calculate it like that. So if I save the file and refresh the page, and here in our polylines array, so A to B is going to be the first polyline. I can say get polyline length of polylines of 0 3 kilometers and 700 meters. So this is now the blue line. If I make it shorter, 2 kilometers 252. If I add a C point here, this is going to be the same, so A to B did not change at all. But my second polyline here, so polylines of 1, here, is 7 kilometers. So this seems to work. I know the distances in Joensuu quite well, and so these functions seem to give correct result. These are not yet useful for figuring out what the windy portions are, but they will be useful in the later on. So now let's move to the figuring out if we are inside, for example, the forested area here, or if we are not in a forested area here. So I'm going to put markers in the places that are not forested, let's say. So how to do that? Well, not very easy, but doable. So in our update context function, when this context is updated and we have the results, we hide loading. But how about we also show windy regions? Okay, another function. It doesn't exist, but I'm going to create it. And let's get the first polyline to work with. So just for testing purposes, we don't consider this ABC, but we will just consider this AB to see how to simplify, and then we extend. So points equal to get point array from polyline, and I'm gonna say polylines of 0. So the only one in this case here. So now we have some points. Now how do we say if these points are inside of a windy region or not? You need to go through each of the point of the polyline and check if it's inside one of these polygons or not. So we need to verify if this point is inside any forested area. So computationally expensive, but computer can do these things quite rapidly, so let's try it out. So we say for if let's call it inside the I point into polygon, some polygon, we don't have it defined there, then show a windy point. We will have to do that. Now what is this polygon? We really have to go through all the polygons of all the forests, for example. So I'm going to say here for var j is equal to 0, forest. Okay, forest is going to give me again the Google object, so I can actually get the same point array from a specific forest Google object, this Google polygon, more or less. So here I could get the point array from the forest at I. So maybe. Yes, thank you. Thank you. So now, if it's inside this polygon, it's a safe point. Any polygon. So for every point, it will be considered initially as we could keep this as a property of the point as well. So it will be useful later. So I'm going to say points of I. So the ith point is going to be unsafe. But if it's inside any forest polygon, I'm going to say that it's safe. So this is what I'm going to do now. Go through all of them, through all the forests. If it's inside the polygon shape of the forest, it's going to be marked as safe. Now, how to get the inside of the polygon is not easy. I'm going to hopefully find the same example I found yesterday. So point in polygon JavaScript. I think I found this example and it's quite good. The system, the algorithm for doing it is not very complicated. Many of you probably know it. So what is happening is that you have this kind of arbitrary shape here. And if your point is going to be outside the polygon and you start shooting rays in all the directions that you're going to send, if you focus on the ray that goes towards the center of the polygon, then you will see that it intersects the polygon twice. Now, if your point is here and you're going to do the same thing, it will intersect the polygon 1, 2, 3, 4 times. But if your point is inside the polygon, it will intersect once, or sometimes maybe 1, 2, 3 times. So you have this odd versus even case. So if your point is inside the polygon, it's going to intersect its edges an even number of. If it's inside, it's going to be an odd number of times, and if it's outside, it's going to be an even number of times. If you check this, it's most likely what it is doing. There is documentation here, and I will put the link to this in my code. And there is another link here where it is based from. Yeah, so this one, okay, I happened to call the function correctly. So I call it with a point. And I think this VS is supposed to be the polygon, yes. But I need to modify it slightly. So this one uses here first component of the point and second component of the point. So this is like X and Y. But we have LAT and LNG here. So otherwise this function as such will not work for our data structures, for our data types. Oh boy. So many things that I tried to get done. But okay, so now the points are coming here, are being checked if it's in the forested region. Let's also return these points for debugging. I really hope this will work. If not, then I have to fix the bugs fast. Okay, refresh the page. no bugs now, so show windy regions. It returns me 17 points. So these are now points coming from A to B, and each of them have LAT, LNG, but now also have the safe attribute. So all of them are unsafe points apparently. But if we look here, it's most likely correct. I mean, this example definitely has this point that is unsafe. So if I call this function again now, it doesn't work. So I would assume some of these safes become true. Okay, some error here. Okay, for some reason this code is not, this breakpoint is not even triggering, so it's very strange. I refreshed the page once and okay, now it triggers. I'm not sure. It could be a bug. Sometimes these developer consoles generate bugs at times and need to be refreshed. It's something you just learn by. Okay. But we get some error still. So this polyline is defined. It has different properties here. And then get path doesn't work. No, this works. So, okay, it could be from the forests. So let's check that one as well. So forests, I have apparently 26 forests somewhere here. And if I call get point array from forest, does it work? Yeah, I think this works. The first one has 95 points, but you can see here that some of these forested areas have very, very high precision. So these polygons have quite many details there. But it doesn't work. So so we go through all the points of the polyline, and then for each point, this is J, should be J. So this loop is the J loop. Most likely this is going to be the problem, and it also can generate the error if there are more points in the polyline than the number of forests. Then this will give the error here. I hope this solves it, because so show windy regions now. Okay, still false everywhere, but it could be correct, I hope. In this case now, definitely these points are in the forested area, so still doesn't work. Okay, I'm going to debug this show windy regions function by putting a breakpoint somewhere here. And now I redrag this marker, and at some point it's going to get to this step. So now I have a polygon that looks like this, LAT, LNG, everywhere it looks okay. And I have a point, so points of I is 0, so I have also a point. And the inside function, I can step into the function here. Oh my! This should be also LAT and LNG here. So again, the first and second component of the point, my point is LAT, LNG, but here it's looking for 0 and 1. So when I copied this function, I didn't read it carefully enough. I needed to modify this as well.
What positive points?
So these points.
Yeah, but
So this is all the points making the blue line on the map here. And the polygons, one by one, all the green markers on the map now. So, sorry, not markers, green areas on the map. So they are not connected to each other. They are separated. And we have 17 green areas. And the first green area has quite many points, 95 points. So one of these forests, maybe this one, has more points on the border of its polygon than I have points in this polyline from A to B. Okay, but I fixed this part now. Let's see, does it now work? Show windy regions. Still falls everywhere. Moving it here. It definitely shouldn't have any all falses now, so still a problem. Wow. Oh, I didn't save the file. It's red here. Come on, please work. This is the, let's just move it here already in the first test to speed up some. Well, some hope.
some true.
Some true, yes. Great. So, I want to draw them as markers on the map. So I will use some small red markers for these areas, and I'm going to call them wind markers, a new array. These wind markers will be we also need to remove them. So if we have markers showing and then we do some change, we always want to clear the markers before we recreate the new ones. So here we go through them and we just say remove from map. And after we remove all of them from the map, we initialize the wind markers with an empty array. And here, after we have the points that are correct, we can actually do this also down here because it's grouping together the marker region with the detection part from the top. And here, we can just go through all the points again. And if they are not safe, so if they are not safe, now we create a new marker. I'm I'm gonna copy the code from our markers that have the labels. I think this is probably enough, and I will modify it. So if it's unsafe, our marker is going to be a new Google Maps marker at the location points of I. So we already have the location. On the map, we don't want it to be draggable. We don't need any label for it. I just want it to mark that it's going to be a circle that is going to be small enough but still visible. So I'm going to cheat here and to look at some notes I have that look good. So a red marker with opacity, it can have some opacity. Stroke, I don't want it to have stroke, but I want it to be, yeah. So no stroke, that means I'm gonna make its opacity to 0. It's one way of doing it. This should look good, I think. And I'm gonna add this to the wind markers object so that I can later work with them. Refresh the page. Some red markers appear, so this is hopeful. Some red markers appear here, but not here. Now you're going to see the problem that this polyline has 18 points now. I mean, when it comes from the directions in OSRM, it keeps the representative points here. But I would really like to know that this is a windy region, this is a windy region. I would like to have points scattered all across this polyline, even though I'm not getting that. So this is one thing that I still want to do in the next 10 minutes, and then we are done. So I'm gonna do that in the simplest way I know how. I'm going to interpolate this line, this blue line here, so that points are gonna be artificially generated on top of it every 10 meters or so. So every 10 meters I'm going to have points on this line. There can be much better ways of doing it. You should probably work with segments instead, so detecting these kind of segment intersections and keep full segments. But if I'm gonna have equally distributed points on the line, if I count how many points are red, I'm gonna have a proportion of how much wind I have. Like how many are red versus how many are not visible. If it's half and half, then half of the route is gonna be windy. So it's gonna solve my problem in a way that is also relatively fast to implement and a little less geometric intensive. But I still have to implement this, so I will try to concentrate and maybe also cheat a little bit. So first thing what I need here is in the show windy regions, I get the points from the polyline, but I want them to be interpolate points. So I need a function to interpolate between all pairs of points on a given polyline. We can call them segments. So one big route is made of many segments. One less number of segments than the total markers. So this one is going to be something like, let's say, new path, empty array, and we are going to go until the second last point again, similar as before, and we are going to say that the segment is interpolate segment something like that, and this segment is going to be added to our new path array by concatenating whatever is inside it from the previous segment that we interpolated and from the current segment that we interpolate. Here we return it. But now we still need interpolate segment, and this one is 2 points as a parameter, so we just get 2 points, and we want to get evenly distributed every 10 meters points along the line defined by these 2 points. So I'm going to say P1 and P2. First thing what we need to do is calculate the distance between them. And then how many steps are we going to need? It's depending on our threshold, so now we say 10 meters, so I'm going to say steps is equal to that. And now what we are going to do is prepare an empty array again and populate it with the intermediate points. So I know how many they are, and I'm gonna say directly speed up a little bit to push a new point here, but this new point I have to define it. So the latitude is going to be the latitude of the first point parameter from here multiplied by, now bear with me for a second, 1 minus I divided by steps plus P2 lng multiplied by I divided by steps. So you can visualize what happens in the, sorry, I'm making a mistake here. This is the LAT part in the top, and this is the LNG part in the bottom. So what happens here, when you're halfway, if you just want the middle point, then this 1 minus I by steps and I divided by steps would be equal. So you would just get half of the latitude from here and half from here. That's the middle point. But here we have to go through different steps. So you are gradually going further away from the P1 and closer away to P2 as your step count increases. So more or less what we are doing now with P1 and P2 is that we are gradually moving from each location. So in the beginning, I divided by steps is going to be 0. This is going to be 1, so in the beginning we actually have P1. And here this is 0, so all of this goes away. So in the beginning we actually have P1. But then gradually we're getting more and more influence by P2 in this for loop. So this is one way of doing this interpolation, and I hope it's going to work.
That should be LNG.
Isn't that
P1.lng.
Second line?
Yes, thank you. Thank you. Both of you. I think two people at the same time. So we have the points here, and we want to return them because that's what we expect. That's what we expect here for the segment, and then here we get the path. So let's see what we get now. Hopefully no errors. Okay. Okay, so we actually see here something. Oh, look at that. It actually goes through some forested area, even though some of these things are probably also mistakes, and the data is not perfectly accurate, and Google Maps, OpenStreetMaps have different quality of the data, but
So the interpolated lines are not shown in red.
I'm sorry?
The lines in between, interpolation, we are doing the interpolation in between.
So interpolation is happening here now. That's why we get this full red line, except these places, because these are inside the green polygon. So these points are existing in the interpolated path, but they are not showing anywhere because they are unsafe, according to the definition that we have. So now if I move B here, it looks like this. It's green, it's red here because this part is safe. You're going through the forest, so it's not going to be windy. So tomorrow what we are going to do is we are going to wrap it up. We are going to use also the direction information of the wind, at least visualize it somehow, maybe an arrow showing where the wind is coming from. We are also going to calculate what is the proportion of this, or what is the distance that you are supposedly traveling in the wind. And I will try to get it as useful as possible, but this stands more or less as an example and ideas for future work. So it's going to be a usable app, but I think it can become much more useful in the future with what we discussed in the exercises before. One more thing I'm going to do at home, but it's a very small, I think just a couple of lines of code. Now it's not doing it for the whole path, so if you remember we did it just for one polyline, so it should adapt to be calculated between all of these. Is it hard to do it now? No, well, it's not the best way to do it, but let's just do it, even though code quality decreases a little bit. So I'm going to make here a loop for k, polylines length, and here our polyline is going to be the one from k. So I will go get the points from everything, interpolate the points from all of them, add markers on top of all of them, and the reason why code quality decreases is because of this extra indentation that I type here. So usually you want the code to fit in your screen nicely, not to have so many indents here. So this is now compromise speed for quality, and hopefully now it works. So it processes all of the polylines, no matter how many there are. Okay, so thank you, and tomorrow we continue with this and wrap it up and polish it so that it becomes more useful on the mobile device.